So 1 to 6, we have two main categories. What was one of the main words of the day? Weight. The other one is mass. So we have some weight answers, we have some mass answers. Now let's do the mass answers first. What did mass measure? The amount of matter in an object. So something about amount of matter for mass. If you see anything about the word matter, I'll take it. If you don't see matter, then probably not. The unit for mass is kilograms, kg for kilograms. Weight, what is weight about?
The Earth's gravitational force.
It is the Earth's gravitational force or any planet's gravitational force. Even if you went to another planet or the moon or the sun or somewhere else in space, you would still have a weight. What is the unit for weight? It is newtons. It's not enough to just say it's a gravitational force, because as we talked about Friday, there's a gravitational force between me and what else?
Everything.
Literally every other object in the universe. Okay? Weight is only the force between me and my planet that I'm on. So 7, which one of these varies or changes with location? Weight. My weight on the moon would be more or less? Less. Why? Why would my weight be less on the moon? The moon is smaller. If I went to the sun, my weight would be more, because the sun is bigger. Okay? I'm the same everywhere, but my weight will change in different spots. 8, we have the equation W equals mg, which, let's cut down for a second to 28. What's 28's equation? F equals ma. What is force measured with? Newtons. What did we just decide that weight was measured with? Newtons. They both have, which is measured with kilograms. What's g?
That's gravity's acceleration.
Which is 9.8
meters per second squared.
meters per second squared. An acceleration is measured with the unit meters per second squared. So this isn't really a new equation. Okay? W equals mg is really just F equals ma, because weight is a, what was the definition of weight? It was
Earth's gravitational force.
Earth's gravitational force. The weight is a force. As long as we're talking about Earth, Earth's g is 9.8. Again, if we went to the moon would have its own g, but it would be a number that's smaller. And the sun would have a number that's greater. And other planets, depending on their size, are going to be bigger or smaller than 9.8. But it's the same equation, really. If you want to be a helpful neighbor, write on your neighbor's paper in tonight's homework, if you want the weight, if we know the mass and you want the weight, what would you look to do? Multiply by 9.8. And if you go to do the homework tonight and you don't want the weight, but you want the mass instead,
Divide by
90% of your homework tonight is going to be just either multiply or divide by 9.8 as appropriate. There's not really a lot of twisting, turning type questions in the homework tonight. 9 to 14, we're going magnetic with a star, electric with a star, gravitational with a star, nuclear, not with a star, weak interaction, not with a star. If they mess up the stars, let's take like half a point a star, but not more than 1 full point if they messed up multiple star issues. 15's electric, also in 16 called mechanical and frictional. 15 and 16, even if they got some stuff switched up in terms of their order, those are 3 synonyms. So on 15, if they said mechanical, and then on 16 went back to electric and frictional, so be it. But we're looking for 3 different words there. 16, if they only get 1 word instead of 2, give them half. 17, nuclear and weak interaction are both in the strongest club. If they only did 1 of those, only give them half. 18, gravitational is weakest. 19, the Newton is the name. Kilograms times meters per second squared is the definition, so that's 2 points, so each one there is a point. 21 is a distance. 22 is the study of forces that cause motion. If they somehow said that motion caused forces, I'll go half. They at least had the right words, but not in the right way. So it's the study of forces that cause motion. 23 is study just of motion. 24 is Galileo. 25 is an object's resistance to a change in motion. If they said an object's resistance to motion, period, I'll go half today, but not anymore. It's an object's resistance to a change in motion. 26, almost certainly we're going to end up with some half-point issues on some people's papers because there's a lot of stuff. So one thing we're looking for is an object at rest tends to stay at rest. That's something. An object in motion tends to stay in motion. That's something. But as part of that something, they need to say at constant velocity. If they didn't say at constant velocity, they're down at least a half already. Unless it's acted upon by a net outside force. So if they didn't have the word net in there somewhere, that would be like a half point kind of example. And if you add up those halves, they might not have scored even though they did have a lot of right stuff. So object at rest tends to stay at rest, half. Object in motion tends to stay in motion, there's a half. At constant velocity is a half. The word speed does not work as a substitution there. Unless it's acted upon by a net, it would be like a half point kind of word. Outside or external is a fine word, force. If they missed two little things, that's a no-go. Because I said about 5 things there that were half-point issues, and it's not a 2.5-point question, it's only a 1-point question. 27, if they said at rest, that would be worth half a point. If they said at constant velocity, that's our other half of a point. Synonym for at rest would be a velocity of 0. Synonym for constant velocity would be an acceleration of 0. I could take either of those as well. 28 is F equals ma, as we earlier said. 29 is accelerations. So next time up is our last reading part in chapter 6. So we'll read 6.6 and we'll read 6.7, but there's only 3 new points of reading. Slowed down dramatically. And one of those points isn't really even new in my opinion. Relative to today's quiz, from number 9 and down, that all looks to be the same to me. Yes. 1 to 6 combines with 7 and just moves to the bottom, but that's still the same thing. You'll have to... Oh no, you won't even have to do the name. Sorry, it'll be a 5-point question. So I'll say, for mass and weight, do the definition, do the unit, and tell me which one changes with location. 8 stays the same to do the equation. Then this became a question. You'll fill in the blank. If you want to find weight, then blank. You'd say multiply 9.8. If you want to find mass, blank. You'd fill in divide 9.8. So that becomes a question from that concept. And then there will be 2 little mathy questions at the bottom. So maybe I give you mass and I want weight. Maybe I give you weight and I want mass. Maybe it's like an F equals ma question, like the 1 to 10 was that we're about to look at. But there will be 2 mathy, problem-y kind of things at the very bottom of the page just to make sure you can do the basic mathiness of this. Homework we're doing today is from 11 to 18. 11 to 18 all looks fairly normal to me, like you're just going to multiply or divide by 9.8 a million times. Another thing that's just worth mentioning is probably the fact that this book is probably, I don't know, a few kilograms, call it, I don't know. That's probably not too kilograms. Let's call it 2 kilograms. So if this book is 2 kilograms, what is its weight? How would you figure out its weight if it's 2 kilograms? Go times 9.8. Somebody grab a calculator, do that.
19.6.
It is 19.6. Newton.
Yeah.
Which means right now, there's a force of 19.6 newtons acting on this floor. Which generally, forces cause
Yeah.
acceleration. That's on our quiz, that forces cause accelerations. Which word did I leave out on purpose to that sentence?
Unbalanced.
Unbalanced. Because right now, this book is not accelerating because it does not have an unbalanced force. It has a force of 19.6 that's pulling it toward the center of the earth. What's the balancing force on that right now?
The table.
The table. The earth is pulling it down and the table is pushing it back up. The force of the table is how many newtons? Also 19.6. If somehow I had a magic table and the force of the table were 22, what would that book do?
Go on.
It would go up a little bit, sort of slowly, but it would accelerate up. What if I had a magic table with a Newton force of 1,000? We'd be
Like rock.
rocking in that book out of the room. What if this table had a force only of like 18 newtons?
And slowly start.
It would sort of slowly fall. What if the table weren't there? The 19.6 would take effect. So the homework does do one question that kind of examines a concept like that, okay, where they're asking you a little bit about weights and things they are or aren't going anywhere. I think you can cut that now.
All right.